All right, so we're back talking about some of the sample problems in your 1.5 homework. The next series of questions we're going to talk about have to do with this physics formula. And you can see that it has to do with the height of an object after it's projected into the air. It says, for example, a projectile is launched from the ground level with an initial velocity of v sub 0 feet per second. Neglecting the air resistance, its height in t seconds after launch is given by, and then we've got a formula. S equals negative 16 t squared plus v sub 0 t. This negative 16 always shows up in these problems because it has to do with the pull of gravity in feet per second. You may do this problem sometime in meters per second in a physics class and see a different number, but ours is in feet per second in our algebra class. And then this v sub 0 has to do with the initial velocity. In other words, how hard is this thing thrown? So here you are on the ground, something is launched into the air, launches up into the air, it hits some high point, it comes back down to the ground. And it tells us like that the height is a function of time. So time is, after 1 second it's so tall, after 2 seconds it's so tall, 3 seconds, so on and so forth. We could graph it, and we will do that in the next chapter. But for now, we're just doing the quadratic equations with that. So question A is find the time. So find the time, looking for t is time, that the projectile will reach a height of 128 feet. So the A part is we want S, the height, how tall it is, to be 128 feet. So say, for example, there's 128 feet. And it does tell us I need to know the velocity, don't I? 96 feet per second. So I am going to need to put that in for v sub 0. It's 96. So I'll have the equation. I had too many variables. But whenever the height is 128, it might be 2 times that happens. It may go up and reach 128 feet, go a little taller, come down at 128 feet before it hits the. There could be answers. There oftentimes is. So anyway, our equation is S is 128. The negative 16 t squared was given. They told us to plug in 96 feet per second, or 96 for our velocity t. And it was launched from the ground, so we don't have a number on the end here. Okay, so here's our equation to solve. It is a quadratic equation, so I'll bring everything to one side, get it in standard form. I'm going to go to the left side just because I like my squared term to be positive, but that's really up to you. But if I bring this over to the left, I'll make it positive 16, negative 96, and the 128 is staying on the left, so don't change its sign. Now sometimes these will reduce nicely. You can divide maybe by the 16. I'm going to see, I think 96 divides by 16. Let me check that out. It does, but does 128? Oh good, it does. Everything divides by 16. So I'm going to divide everything by 16 just to reduce it. Again, that's optional. 96 divided by 16 was 6. 128 divided by 16 was 8. And then 0 divided by 16 is 0. So no harm done there. Everything's divided by the same amount, so we haven't changed its value, just made it look a little easier. Much easier quadratic equation. If you hate the quadratic factoring, you can always use a formula. A is 1, B is negative 6, and C is 8. But this is factorable. A minus 4 and a minus 2 will FOIL to give me a positive 8 on the end, and a negative 6t for my middle term, so that works. Then set each factor equal to 0, and you get 2 solutions of positive 4 and positive 2. 2 plausible answers, and I mentioned earlier in the problem, and that's because you could hit a height of 128, go a little higher, and come back down and hit that. So it looks like at 2 seconds, it hits it the first time, then it goes up a little higher, and then at 4 seconds, it hits that height. So both answers are included in the solution set. There is a B part to this one, so that's just answer A. For B part, let's see, where's that at? On B part of this question, notice it says, when does it return to the ground? So how does it take a projectile to hit the ground? So back to our little drawing, you've got some projectile goes up in the air, hits a high point at some point, and then comes back down to the ground. So if it's hitting the ground, every time it says wording, hitting the ground just means the height, which is s. Remember, it says in our reading that's the height of the object after t seconds. So its height is 0 when it's on the ground, right? So that just means do this problem again with s equals 0. So writing our problem as, here's B part. Remember, it was s equals negative 16t squared plus 96 is our velocity, t. So s is 0 in our problem, which really helps us out a lot. It makes it easier computational-wise, right? So to solve this, although it kind of looks odd to us maybe for a quadratic because it doesn't have a third term, but you could do a is negative 16, b is 96, and c is 0 in this one. So that you could do it that way. Or you can use your factoring, or I'm going to divide. You know, I like to do that just to make the problems a little easier. Everything divides by 16. And I'm even going to divide it by negative 16 to make my signs a little nicer, more positive. So 0 divided by negative 16 is 0. Negative 16 divided by negative 16 makes 1t squared. 96 divided by negative 16 is negative 6t. So here's what you've got. 0 equals t squared minus 6t. So it's not really an unfoil situation. It's you know, it's an easier factoring problem. Actually, you can factor out the common factor of t and have t minus 6 equals 0. So your two factors are t equals 0 and t minus 6 equals 0. There's one of your answers. And then t equals 6. So again, two plausible answers to this. So whenever you write this solution set, you'll say 0 and 6 both work. And that's because before it moved off the ground or was projected from the ground, it was at 0 seconds. Then it went up, 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 hit a high point, came back down. It took it 6 seconds to come back down to the ground. So the answer is 0 before it moved, and then 6, which 6 I believe is the only thing you want to answer here because I think the wording is such that says, let's see if I can find that, such that it says, does it take object to go up and come back down? I'm looking for that right now. Yeah. Yes, so the 6. How long does it take it to return to the ground? So only the 6 would answer that particular question. All right, then we get to do that again. All right, so let's practice that again on number 12. It's really the same question, but it's good practice again, right? Okay, number 12. Let's do that again. So same question, same equation. You always see this s equals, and s is the height of the object after t amount of seconds, and it's always something starting from some position, going up, 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 and then hitting a high point and coming back down, hitting the ground. And this is time. This is your time axis. T is, instead of using x's, you know, usually we see x's and y's, and we're doing a little more application here, and it's you know, a real-time example instead of just generic x's and y's. But normally, you know, that's where you'd see your x in a problem. So instead it's t. T is time, and then s is the height. So s and t here. So s is a function of t. All right, so our equation is s equals negative 16t squared plus, there's that v sub 0. We always have to plug in how hard the object is projected, right? How hard it's thrown initially. And it will tell you that in the problem. In this problem it is 80. Neglecting air resistance is height after t seconds after launch is given by blah, blah, blah. Find the times that the projectile will reach a height of 64. So remember, like the last problem, the height of 64, that's this number over here. That's what S stands for. And then we do our quadratic equation solving to solve for that. And then we're going to have to do this one twice again. We're going to have to do B part. This is A part. And B part is when it returns to the ground. And the height and when it's returning to the ground is 0. So we're really just solving the quadratic equation we have here twice. All right, so just to remind you, quadratic equations, we start in standard form. So I'm going to bring everything over to one side, making that positive 16t squared minus 80t plus 64 equals 0. Now, if you can and you want to, divide by something to make those numbers easier. 16 times 4 is 64, so I know that'll go. And I think 16 times 5 is 80. Let me check that. I believe so. 16 times 5. Yes, so 16 will go into all three of those terms. So why not reduce down a little bit? 16 divided by 16 is 1t squared. Negative 80 divided by 16 is negative 5. And 64 divided by 16 is 4. And then 0 divided by anything is 0. So we're allowed to do that. All right, then you can use your formula or factoring. This will be t times t to get t squared. Negative times a negative to get a positive on the end. I need 4 times 1. Notice how that's going to work out for me here. Not everything is factorable, by the way. If this would have been a 7 in the middle, I could not have got this to work out, and I would have had to have used the formula. But this one worked out nicely. It is factorable, so I kind of like to do it that way when I can. I think it's a little faster. Anyway, so I get two solutions of positive 4 and positive 1. Again, that is plausible because it goes up after 1 second, it hits 64 feet, goes up a little higher, and then after 4 seconds, it comes back down, it hits 64 feet again. So those, again, are times in seconds. For B part, remember that's the hitting the ground example, so I have S is 0. This is a little easier actually because I don't have the third term. I can directly just divide out the negative 16 or positive 16, whatever you prefer. But you can divide to make this a little easier. I'll have 1t squared. I just like a positive number on my leading coefficient. So I prefer to do that, but it's not required. So it's a funny looking quadratic because it's missing its c term, but you can factor out the common factor of t, and actually factors a little easier for us because of that. And then again, notice if I distributed t times t is t squared and t times negative 5 is negative 5t. There's just the two terms there. So that is that. They're equivalent. Then I can set each part equal to 0 and get two solutions of 0, 5. Remember, t equals 0 is the time like before you threw it. So we're looking for that. Although it is a valid algebraic solution, but t equals 5 is the answer for after the projectile was launched. After 5 seconds, it came back down and hit the ground. So 5 seconds. All right, so that's like your number 11, or 12, sorry. And then look, you get to do it again, number 13. But it's very similar. They're all just practice of the same skill because it's kind of a complicated process. I thought a little extra practice would be good for us. So 13, again, I'm going to skip over. Oh, sorry. And then 14 again. Okay, but I'm going to go ahead and skip down to number 15. But you're going to be really good at these after you do. And if you need help on another example, just always let me know and I can add more in. But I'm going to skip down to your number 15 and end with this one. It's actually a little easier. You'll be glad to know it's a modeling question, which means they've already modeled an equation that fits a scenario. They've gathered some stats and they've made an equation that fits some situation they're looking at. In this situation, it's the sales of SUVs in the United States in millions for the years 1990 to 1999. It's modeled by this equation. So good news, the equation is given. We just have to interpret it. It says x equals 0 is the year 1990, x equals 1 is 1991, and so on. So if we're using this model for the sales in 1992, what are we going to do? It said x equals 1 is 91, so I bet that's x equals 2. So we just need to plug in x equals 2 and work this out. So plugging in a 2 for all of our x's, not even what I would consider algebra. I would consider that more arithmetic because we're not going to have to use our quadratic formula. So we plug that in and we can directly use our calculator, plug those numbers straight up, and y equals 0.016 times 2 squared plus 0.124 times 2 0.78, and it gives me 1.099. It says round to the nearest tenth, so tenth place is right there, so the 9 is definitely rounding that up to 1.1, and that is in millions, right? So and it's already got the word million there, so we just need to type in our 1.1 for our answer there. And is that everything I need? Oh, and I just wanted to say it could be a more complicated question if it would have said, like, what year did it reach 2 million? Say, for example, we put in 2 here, then we'd have a quadratic equation. We'd have to go back to our skills we were using in the other problems. But this one told us the year. The year is the X amount. We're able to plug the year 2, X equals 2, which represents 1992, and work out to find the sales in millions. Dollars there is 1.1. All right, hope that helps.